In the previous lecture, we had discussed the concept of the post hoc tests, that what is meant by the post hoc test and why the post hoc tests of ANOVA are needed, because least significant difference is a post hoc test of ANOVA. So least significant difference was developed by Fisher in 1935. That is why it is known as Fisher's least significant difference test. And this is a post hoc test of ANOVA, which is done after finding out significant difference between 3 or more sample means under ANOVA, and we discussed in the previous lecture why this is needed. This is a multi-step pairwise comparison, and it establishes which means are significantly different from each other. And the main concept of the LSD calculation is to find out least significant difference between two means. And this is the formula in which the t-value is taken from t-distribution table at v, which is degree of freedom within, and alpha, which is the desired level of significance, and these are taken from the two-tailed t-distribution. And the variance within is taken from the ANOVA table, and n is the number of observations in a given sample. So these calculations, they are done on pairs of means. And if the difference between a mean pair is greater than LSD, then that difference is said to be significant difference. And these tests are conducted for all pairwise comparisons in a given experiment. And if the number of observations is same for all of the samples, then only one LSD value will suffice. And this LSD calculation has to be done at different levels of significance. And first of all, it is done at the level of significance of 0.05, and at this level it is done for all of the pairwise comparisons. Then in the next step, it is calculation at 0.01 level of significance, but at this level only those pairwise comparisons are made which were found significant at 0.05. And then the next is the calculation at 0.001 level, and this is also done for all those pairwise comparisons which were found significant at 0.01. And if we find in our analysis that there is no pair which is significant at 0.01, then there is no need to perform 0.001. So 0.05 is done for all possible pairwise comparisons. 0.01 is done only for those which are significant at 0.05, and 0.001 is done only if there is a mean difference which is significant at 0.01, and this is performed only for those pairs which are significant at 0.01, right? So this is the general scheme that we discussed in the previous lecture. So here we have our exercise number 1. So this is the mass of starlings sampled from 4 different roosting places: reed bed, tree, building, and cliff. And here are the descriptive statistics and the ANOVA summary table. And this you can also use for as an exercise for ANOVA, right? So you can use this exercise for the calculation of ANOVA as well, and for that purpose the F max values and the tabled F values, they are given here, so you can perform that as well. So here we can see that the difference between the mean values is significant, right? The mean values are 90.8, 90.2, 88.2, and 84.2. And the ANOVA is telling us that there is a difference in these mean values, there is a difference in the overall comparison. Now we need to figure out that which means are specifically different from each other. So in the step number 1, we are going to make a table for pairwise differences in means. So the first pair is reed bed and tree, and their sample means are 90.8 and 90.2, and the difference of these two means is 0.6. Then the next pair is reed bed and building, and their mean values are 90.8 and 88.2, and the difference of these mean values is 2.6. Then we have reed bed and cliff, and their mean values are 90.8 and 84.2, and the difference between these mean values is 6.6. Then the next pair is tree and building, and their difference between their mean values is 2. And then the next pair is tree and cliff. Their mean values are 90.2 and 84.2, and their difference is 6. And then we have building and cliff as the last pair, and their mean values are 88.2 and 84.2, and the difference is 4. So now the next step is to calculate least significant difference for 0.05 significance level. So here we have the formula for LSD calculation, and the t-value is to be taken from 0.05 significance level at V, which is degree of freedom within, which in this case is 36, and the variance within, which is taken from the ANOVA table, is 20.9. And in the first pair, the number of observations are 10 in each of the samples. So we have our values input here, and we are going to solve them. So 20.9 multiplied by 0.2, the answer is 4.18. We take the square root of this answer, we get 2.045. And this is to be multiplied by the t-value, which is taken from the t-distribution table at 36 degree of freedom and 0.05 level of significance. And we get our LSD, which is 4.147, right? So this is LSD for the first pair of means at 0.05 significance level. And we have to do it for all the pairwise comparisons, but in this case, because the number of observations are same in all of the pairs, therefore this one value is going to be sufficient for all of these pairs. So in the third step, we are going to compare mean differences with calculated LSD, which is 4.147 in this case. Now let's start from the first pair, which is the reed bed and tree, and the difference between their mean values is 0.6. And remember what we discussed, that if the difference between the mean values is greater than the LSD value, then that difference is going to be significant. Otherwise, this is non-significant. So what about this value? This is 0.6. So this difference is less than LSD 4.147. So what we are going to do with this is, we are going to say that this is non-significant. So we are going to put NS in the superscript here. So NS means non-significant, right? So the difference between this pair of means is non-significant. Then we look at the next pair, and the difference is 2.6, which is the difference of 90.8 and 88.2, the difference between reed bed and building samples, and this difference is also less than LSD. So this difference is going to be non-significant as well, right? Then we have the next pair, which is the pair of reed bed and cliff. The difference of 90.8 and 84.2 is 6.6, and we can see that this difference is greater than the LSD value of 4.147. So what we are going to do with that is, we are going to place an asterisk here. So an asterisk symbolizes that this value is significant at probability of 0.05, right? So the single asterisk means that this value is significant at probability of 0.05. And in this case, it means that this difference between the mean pairs, 6.6, it is greater than least significant difference. Therefore, this difference is to be considered significant. Then the next pair is the tree and building, and the difference between their mean values is 2. And this difference is less than LSD. So what we are going to do with this, we are going to write an S, which means non-significant. Then what about the next pair? This is 6. This is the difference between mean values of tree and cliff, and this difference is greater than LSD, so we are going to place an asterisk here, which means it is significant. And then we have building and cliff pair, and the difference between their means is 4, and this is less than LSD. So therefore, we are going to say that this difference is non-significant, right? So here we are done with the 0.05 level of significance, and we can see that only 2 pairs are significant, right? The difference between only 2 pairs is significant. Rest of the pairs are non-significantly different from each other. And these 2 pairs are reed bed and cliff, and tree and cliff. So now you see that how helpful the post hoc test of ANOVA is, because in ANOVA we got the result that the mean values are different from each other. At least one mean is different, right? So what we get here in the post hoc analysis is that which means are specifically different. So now we can see that there is non-significant difference between reed bed and tree, between reed bed and building, between tree and building, between building and cliff. And there is significant difference between reed bed and cliff. There is significant difference between tree and cliff. So now, should we stop here? We can stop here, but it is advisable to do further analysis to check this at the next level of significance, which is 0.01. So we have to repeat this calculation for the significance level of 0.01, but this time we don't have to do this for all the 6 pairwise comparisons. Rather, we have to do only for those 2 which were found significant at 0.05 level. And this is the same formula, but the t-value is going to be different because this is now taken from 0.01 level of significance. And the variance within is taken from the ANOVA table, and the number of observations are 10 in each of the samples. So we have 20.9 multiplied by 0.2, we have 4.18, we take the square root, and the answer is 2.045. So when this one is multiplied by the t-value, which is 2.719, we get our LSD, which is 5.56. So this is LSD for first pair of means at 0.01 significance level. So do we need to repeat it for the second pair? Yes, we need to repeat it, but because we have the same number of observations, so if we are going to repeat it, we are going to get the same value, right? So we are taking this value and we are comparing this value with the differences between the means. But which means are going to be compared here? Only these 2 means, right? Because these 2 means were found significantly different at 0.05 significance level. So only these 2 means are going to be checked at LSD of 5.56, which is the LSD at 0.01 significance level. So when we look at the first value, it is 6.6, which is the difference between mean values of reed bed and cliff, and we can see that this value is greater than 5.56. So it means that this is highly significant. This is significant at 0.01 as well. So what we are going to do with this is we are going to put another asterisk. So this double asterisk signifies that this value is significant at probability of 0.01. And in this case, this is LSD value of 5.56. So we can say that the difference between this mean pair is highly significant. And then the next pair of mean which we need to compare at this level is 6. And this is also greater than 5.56, so we are going to place an asterisk over here as well. So now we have both of these values significant at 0.01, which means that we can proceed for 0.001 level as well and figure out that whether these values, they are significant at 0.001 level as well or no. So we are going to step number 6. We are going to repeat this for the significance level of 0.001, but only for those pairs which were significant at 0.01. We don't have to do that for all of the pairwise comparisons. This is the formula. The t-value is going to be taken from 0.001 significance level at 36 degrees of freedom from the two-tailed distribution. And the variance within is taken from the ANOVA table. The number of observations are 10 in each of the samples, and we get 4.18. And this, when we take the square root, this is 2.045. We multiply this one with the t-value, which is 3.582, and we get our LSD, which is 7.325 in this case, right? So this is our least significant difference at the significance level of 0.001, right? And because we have 2 pairs which were significant at 0.01 level, so we have to repeat this for every pair. But because the sample sizes are same, so if we are going to repeat that for the second pair, we are going to get the same LSD. Therefore, we jump to this one, this table, to compare the mean differences with calculated least significant difference, right? And you can see that we have imported the same table that we had at the significance level of 0.01. And what mean values are we going to compare at this stage are the 2 mean values which were highly significant, which were significant at 0.01 significance level. And the LSD that we have calculated is 7.325. So let's see that if our values, our mean pairs are different from this one. So these are different, but these are less than LSD. So what we are going to do with them, are we going to say that these are very highly significant? Because 6.6, which is the difference between reed bed and cliff, is less than 7.325, which means that this is not very highly significant. And same is true for the next pair, which is tree and cliff, because their difference is 6 and this is less than LSD of 7.325. So we are not going to put the third aesthetic for significance level of 0.001, rather we are going to leave them as such. So here we have our result table of LSD, which is the pairwise comparison of means through Fisher's least significant difference. And here we can see that the difference between the means of reed bed and tree is non-significant. Difference between the samples taken from reed bed and building is also non-significant. The difference between reed bed and cliff samples is highly significant. Then the difference between the samples taken from tree and building is non-significant, and the difference between tree and cliff samples is highly significant. And the difference between building and cliff samples are non-significant. So here we have the detailed analysis, which was not shown in the ANOVA summary table, right? And we can document our results in this form. You can use any format, or you can write in any of the formats in any of the manners, but this is a general and the basic mode in which you can describe your LSD results. So the difference in the mean mass of starlings roosting at red reed and cliff is highly significant. Probability is less than 0.01. Difference between mean mass of starlings roosting at tree and cliff is also highly significant. Probability less than 0.01. While differences between rest of the mean pairs are non-significant, probability greater than 0.05. So in ANOVA we said that there is an overall significant difference in the mean values, and in LSD we are going to identify precisely which mean pairs are significantly different from each other, right? So this is a post hoc test of ANOVA, which is performed after ANOVA. ANOVA is the omnibus test and LSD is after that, a posteriori test, which is performed after the event, where event is statistical test, right? So this is our exercise number 1. Now we have our exercise number 2 for today, which is about the mean otolith diameter of fish grown at different temperatures. And remember, we solved this problem, we did this exercise in ANOVA as well. And the ANOVA value that we got was 12.89 F value, and which was very highly significant. So this analysis, this ANOVA result that showed us that there is a significant difference in the mean values, right? But which mean values are specifically different from each other, let's find out through LSD. So in the step number 1, what we are going to do is we are going to make a table for pairwise differences in means, right? So the first pair is sample number 1 and 2, and the difference between their means, difference between 9.017 and 6.025 is 2.992. Then we have our second pair, which is sample number 1 and 3, and the difference between their mean values, the difference between 9.017 and 4.847 is 4.17, right? And then we have our third pair, and the difference between their mean values is 1.178, which is the difference between 6.025 and 4.847, right? So this is our first step. So how many pairs do we have? We have 6. So we have to do 6 pairwise comparisons at each level of significance. Sorry, we have 3 pairs, so we have to perform 3 pairwise comparisons at each significance level, right? Now step 2 is to calculate LSD for the first level of significance, which is 0.05. And this has to be done for sample number 1 and sample number 2. On this page, we are calculating this for sample number 1 and sample number 2. Why? Because the number of observations are different in each of the samples. So therefore, we have to calculate LSD for each pair differently. So here is the formula for LSD. We have the t value, which is taken at degree of freedom within, which is 136, and the significance level of 0.05 from the two-tailed distribution, and we have taken variance from within. So because we are comparing sample number 1 and 2, so therefore we are putting in the number of observations of sample 1 and 2, which is 50 number of observations in the first sample and 45 number of observations in the second sample. And here we have further calculation, the t-value is 1.978, and the variance which is taken from the ANOVA table is 17.0632, and then it has to be multiplied by 0.0422. The value is 0.72. When we take the square root of this value, we get 0.849. So this is multiplied by t-value, and we get our LSD 1.679, which is for sample number 1 and sample number 2, right? Now, in the second part of step number 2, we are going to calculate LSD for 0.05 significance level for sample number 1 and sample number 3. So we have the input of values, and in this case, the number of samples are going to be different. The number of observations are in sample number 1 are 50, and the number of observations in sample number 3 are 44. So we further input and calculate the values. So we get 0.729. When we multiply the square root of this value with the t-value, we get our LSD, which is 1.689. Now this is LSD at 0.05 for sample number 1 and sample number 3, right? So how many pairs did we have? We had 3 pairs, so we are done with calculating LSD for 2 pairs, and now the third LSD for our pair number 3. And this is the sample number 2 and sample number 3. So we have the LSD value, and in this case again the number of observations are different. The number of observations in sample number 2 are 45, and number of observations in sample number 3 are 44. So when we solve this, we get the value of 0.766. When we take the square root of this value and multiply that by 1.978, which is the t-value, we get our LSD, which is 1.73 in this case, right? So now we have calculated LSD values at 0.05 for each of the pairs. Now it is time to compare the mean differences with calculated LSD. So LSD for the first pair, which is the difference between means of sample number 1 and 2, is 1.679. So let's see that what is the value of the difference between means. So the difference between the means is between sample numbers 1 and sample number 2 is 2.992. And we can see that this value is greater than the LSD for this level, for this pair. So what we are going to do with that, we are going to place an asterisk over here, which notifies that this result is significant at probability of 0.05, right? Then we have the next LSD value, which is the LSD for difference between the mean values of sample number 1 and 3, and this LSD is 1.689. And what is the difference between the mean values of sample 1 and 3? This is 4.17, and we can see that this value is greater than LSD. So what we are going to do with this is we are going to put an asterisk here, which means that this value is significant at 0.05. Then we have our third pair, which is the sample number 2 and sample number 3 mean pairs, and the LSD value is 1.73, and the difference between their mean values is 1.178, which is less than LSD. So what we are going to do with this, are we going to place an asterisk and calling it significant? No. We are going to write an S, which means non-significant. So the difference between this pair of means is non-significant, right? So here we are done with the first level of significance, which is 0.05. Now we have to repeat LSD analysis at 0.01 significance level, but are we going to do that for all of these 3 pairs? No, we are going to do that only for the 2 pairs which are significant at this level. So we are going to repeat it at 0.01 only for those pairs which are significant at 0.05 probability. And the first pair that we have here is sample number 1 and 2, which were significant at 0.05. So we are going to calculate their LSD at 0.01. So we get these values, and we get 0.72. When we take the square root of 0.72, it is 0.849. When we multiply that by the t-value, which is taken at degree of freedom 136 and level of significance 0.01 from the two-tailed t-distribution, then we get our LSD, which is 2.218, right? So LSD for our first pair of means, which are sample number 1 and sample number 2, is 2.218. Now we are going to repeat this step number 4 for our next pair, which was found significant at 0.05. And this pair is sample number 1 and sample number 3. So we have our LSD formula here. The LSD value is T value is 2.612. The variance within is 17.0632. The number of observations are 50 in sample number 1 and 44 in sample number 3. And when we take their LCM and we calculate, we take their sum. This is 0.0427. This is to be multiplied by 17.0632. We get 0.729. We take the square root of this. This is 0.854. This is to be multiplied by 2.612, which is the T value, and we get our LSD. So this is 2.23, which is LSD at 0.01 significance level for sample number 1 and sample number 3. Now, do we need to repeat this one for sample number 2 and 3? No, because the difference between sample number 2 and 3 is already found to be non-significant. So there is no need to do that at probability level of 0.01. So we are coming to the comparison of the mean differences with calculated LSD. And the first LSD, and for which samples we are going to do that? We are going to do that only for those 2 samples which are found significant at 0.05. And this is our first pair of sample number 1 and 2 and second pair of sample 1 and 3. We are not going to do that for sample number 2 and 3 pair, right? So our first LSD is the LSD for difference between the means of sample number 1 and 2, and this value is 2.218. And we can see that our difference between the mean values, which is 2.992, is greater than this LSD. Therefore, what we are going to do with this one, we are going to place another asterisk. Now, this double asterisk means that this result is significant at 0.01, right? Now, the next samples pair is sample number 1 and sample number 3. And the difference between their mean values is 4.17 and their LSD is 2.23, and we can see that the differences between means is greater than the LSD for this pair, right? So 4.17 is greater than 2.23. So what we are going to do with that is we are going to place another asterisk which notifies this pair as highly significant at 0.01 level, right? And we're not going to do that for the next pair. Now, we have found 2 sample pairs to be significant at 0.01. Therefore, we are interested in finding out that whether these are significant at the next level as well or no. So we repeat this for the significance level of 0.001, but only for those pairs which were significant at 0.01. And the first pair is sample number 1 and sample number 2. So we have the LSD values here. The T value is taken from the two-tailed T distribution, and this is 3.364 at 136 degree of freedom within and 0.001 alpha level. And then we have the variance within, and we multiply this by 0.0422, we get 0.72. We take the square root of 0.72, which is 0.849, and then we multiply this 0.849 with the T value of 3.364, and we get our LSD, which is 2.856. So this is LSD at 0.001 significance level for sample number 1 and sample number 2. We are going to repeat this one for sample number 1 and 3, and why we are repeating it? Because the number of observations are different, right? So we have the same values of T and variance within, but this time the number of observations are different. Number of observations in sample number 1 are 50, and number of observations in sample number 3 are 44. So therefore, we are going to get the value of 0.729. We are going to take the square root of this value, and this is 0.854. We multiply that by the T value, which is 3.364, and we get our LSD, which is 2.873. So this is LSD, or the least significant difference, at 0.001 level of significance for sample number 1 and sample number 3. We are not going to do that for the sample number 2 and sample number 3, because that sample pair is non-significant. So now we have our table. So we are importing the same table that we had at 0.01 level of significance, and we are going to compare the mean differences with calculated least significant difference, right? And what sample pairs are we going to compare? We are going to compare sample number 1 and 2, and we are going to compare sample number 1 and 3. So the LSD for our first pair is 2.856. So our first pair is sample 1 and 2, and their difference between their mean values is 2.992. And we can see that this difference is greater than LSD for this pair. So what we're going to do with this is we're going to add a third asterisk. We're going to add another asterisk, and now this third asterisk or this triple asterisk notifies this value to be significant at 0.001, which means it is very highly significant, right? So the difference between our first pair of samples is very highly significant, which are samples number 1 and 2. Then we have our next pair, which are samples number 1 and 3. And the difference between their means is 4.17, and their LSD is 2.873 for 0.001 significance level. And we can see that our mean difference is greater than the LSD at this level. So we are going to place another asterisk here. So we have the 3 asterisk values, which means that these results are very highly significant. Now we have our LSD table, which is the pairwise comparison of means through Fisher's least significant difference. So here we can see that the difference between the means of sample number 1 and 2 is very highly significant, and the difference between sample number 1 and 3 is also very highly significant, and the difference between sample number 2 and sample number 3 is non-significant, right? So this is the table that we have, and now the results. And we can state result in any form, and this is the most basic and general way to report these results. The mean otolith diameter of fish is very highly significantly different between samples 1 and 2 and between samples 1 and 3, probability less than 0.001. The difference between mean otolith diameter of fish from samples 2 and 3 is non-significant, probability greater than 0.05, right? So these are the LSD exercises that we have for today. And in the first exercise, we had 4 samples and we did 6 pairwise comparisons. And in the second example, we had 3 samples and we did 3 pairwise comparisons, right? And in the first exercise, the number of samples were equal in all, the number of observations were equal in all of the samples. And in the second exercise, the number of observations were different in all of the samples. Therefore, we had to do different LSD calculation for every pair of means. So this is how the Fisher's least significant difference, which is a post hoc test of ANOVA, performed.